Okay, this is 2010 FRQ number 5 in the non-calculator section. The function g is defined and differentiable on the closed interval between -7 and 5 and satisfies g of 0 equals 5. So this is our initial condition. The graph of y equals g prime, the derivative of g consists of a semicircle and 3 line segments as shown in the figure above. So this is the graph of g prime. So keep in mind that this is not the original graph of this is not the original function. So another way to look at this is that if we want g, right, so knowing that this is g prime, knowing that our initial condition is 5, if you want g will equal to 5 plus the integral of g prime, right? And then if you want to look at the derivative, that's looking at the graph. If you're looking at the second derivative, you're looking at the slope of the graph. Okay, we had something like this before, and this is going to show up a lot, so make sure you understand the relationship between these three functions. All right, so first one says find g of 3. Okay, so g of 3, based on what I said up there, part A, g of 3 is equal to 5 plus the integral from 0, by the way, 0 to whatever x value that is. So g of 3, g prime, that's 5. So from 0 to 3, 1, 2, 3, from 0 to 3. All right, so that's gonna be a quarter of a circle and a triangle here. So plus a quarter of a circle, quarter of pi r square radius of 2 squared, plus triangle 1/2 base times height of 3. So that gives me 5 plus 4 over 4, that's 1. So pi plus 3 over 2, add up the constants here is 5 and 3/2, we get 13 over 2 plus pi. So that's my answer for g of 3. Okay, then we want g of -2, same thing, it's 5 plus integral from 0 to -2, g prime. Remember, we cannot have the lower number on top, so in order to switch these around, you change this to a negative. So 5 minus -2 to 0, g prime. So from -2 to 0 is another semicircle, a quarter of a circle, which we already know that's going to be pi based on our first part answer here. So 5 minus pi is my second answer for g of -2. Okay. Find the x-coordinate of each point of inflection of the graph of y equals g of x on the interval between -7 and 5. Explain your reasoning. So when we want the point of inflection, that's when the second derivative equal to 0. So in this picture, we're looking for when the slope of this graph is equal to 0. Well, the slope of this graph is equal to 0 right here, and then slope of graph equals 0 right here, and slope of graph right here. So for part B, I have 3 possible answers. I have 0, 2, and 3. Now I gotta look at the slope. Did it change before and after? Because if it changed before and after, it changes concavity, from concaving up to concaving down and vice versa. Therefore, it is truly a point of inflection. So at 0 here, notice how my slope went increasing to decreasing. So yes, the slope changed here. Here, my slope went decreasing to increasing. So yes, slope changed too. And in 3 here, it went from increasing to decreasing. So these are all point of inflection because their signs change. So these are, explain your reasoning, when the slope equals 0 and slope, we can go into further details, but slope before and after changes signs. Now, if you want to be very, very technical, I would suggest you look at the solution posted. They have their wording of how to say it, but I'm pretty sure this is okay too. Okay. All right. Last part. The function h is defined as h of x equals g minus 1/2 x squared. Find the coordinate of each critical point. Okay, critical point means extrema, where you're still in the same interval, and classify each critical point as a location of a relative min, relative max, or neither max or min, and explain your reasoning. So to find a critical point or to find extrema is when you set the first derivative equal to 0. All right, so that means when you take my function that's given to me, h of x, and take its first derivative. So part C, h prime equals g prime minus 1/2 times 2, that's 1, and then x. So g prime minus x, that is your derivative of your h. We're looking for the critical point, so we set that equal to 0. So 0 equals g prime minus x. So in other words, if I move the x over, I have a critical point whenever my g prime, whenever my graph equals x. So how do you do that? How do you know when the graph equals x? Now this requires a little bit more algebra. It tells you that g prime consists of a semicircle and 3 line segments. So if you look up here, you can actually break down g prime into 4 different functions. Find a linear function here, find the semicircle function here, linear function, and set each of those pieces equal to x to find your possible values of your extrema. All right. I don't think there's an easier way to do this, but if there is, sure, right? So let's take a quick look at this first interval between -7 and -2, right? Between -7 and -2, what is my graph? Well, the slope looks like it's rise over run, so 1 over 1, 2, 3, 4, 5, 1/5, and my point is here. So in the interval, so there's 4 pieces between -7 and -2, right? I am going to use this formula, y plus 1 equals 1/5 x plus 7, that's point slope formula, right? And if I clean this up, I get y plus 1 equals x over 5 plus 7 over 5, subtract 1, y equals x over 5 plus 2 over 5. Okay, so that's g prime. When is g prime equal to x? So then I take this, I take x over 5 plus 2 over 5, that's my g prime, set it equal to x, right? And we're trying to solve. So combine like terms, subtract 1/5 x, so 2/5 equals 4/5 x, multiplied by the reciprocal, so you get times 5 over 4, so you get 1/2 equals x. X is 1/2, okay? Now let's take a quick look. We are okay, but the problem is this x equals 1/2 is not in this interval. So in this interval, I cannot have x equals 1/2 as part of my extrema. So sorry, that didn't work. All right, in the next interval between -2 and 2 is a semicircle. So between -2 and 2 is a semicircle. I probably shouldn't put equal to, it really doesn't matter. But a semicircle is, a full circle is x squared plus y squared equals r squared. For a semicircle, it is y equals root r squared minus x squared. So the radius is 2, 2 squared is 4, 4 minus x squared. Right? All right, so now take that, set that equal to x, because that's my g prime, set that equal to x. So x equals root 4 minus x squared, square both sides. X squared equals 4 minus x squared. Add the x squared over, 2x squared equals 4, x squared equals 2, x equals plus or minus root 2, right? So the problem is when you plug this back in, well, anyway, you can check either plus or negative root 2. I think they're both in the interval, and we can check those too. All right. Next, in the next interval, we have this linear function up here. So let's see, this linear function has a slope of rise 1, 2, 3 over 1, so 3 over 1. So my equation between 2 to 3 is y minus 3 equals 3x minus 3. I'll clean this up. Y minus 3 equals 3x minus 9. Y equals 3x minus 6. Okay, again, we're going to set this g prime equal to x, right, because that's what this formula says. Subtract it over, -6 equals -2x, divided by -2, x equals 3. So x equals 3 is in the interval, so we're okay. And then last but not least, we have 3x and 5, between 3 and 5. And that is this piece right here. The slope here looks like it's down 2, right 1, down 2, right 1, so -2. So y plus 1 equals -2, x minus 5. I'm using this point for my point slope formula. So y plus 1 equals -2x plus 10. Y equals -2x plus 9. Okay, set that equal to x. X equals -2x plus 9. 3x equals 9. X equals 3. All right, oh good. So I now have a couple points. I have root 2, 3, and 3. In this case, if you were to plug the root 2 or negative root 2 back into this piece. Because you want x to equal that, you don't really need the negative piece because there's no way this x equals and this is going to equal negative x, right? Because this is already set up as a positive root. So we only need to check positive root 2. All right, so this is the fun part. Here's my root 2, here's 3. We're going to do some testing, see if my my points change, my first derivative, my h prime changes. Because then if it changes, then we know it's a max or a min, right? It needs to go from increasing and decreasing for a max, decreasing and increasing for a min. Okay, so a good number before it, put 1. So I'm going to test h prime of 1. A good number between root 2 and 3. Well, root 2 is about 1.4, so 2. And then h prime of 4. Okay. All right, so h prime of 1 equals, well, h prime 1 is g prime of 1 minus 1. All right, so g prime of 1. So g prime of 1 is above 1. Taking away 1 is still going to be greater than 0. So it's going to be greater than 0, so it's positive, right? G prime of 1, the value is higher than 1, right? Okay. G prime of 2, so this one's g prime of 2 minus 2. All right, so g prime of 2 is 0. Minus 2 is negative 2, so less than 0. So it's going to go decreasing. And then h prime of 4 is g prime of 4 minus 4. G prime of 4, 1, 2, 3, 4. G prime of 4 looks like it's at 1. 1 minus 4 is less than 0 because negative 3, decreasing. So we have a max here, and this is not a max or a minimum, right? Because there's no one increasing, decreasing. So root 2 is a relative max. Okay, that's it.